Hello guys, this is Val from Core Conservation. I'm on a large listed building which has a huge cellar, and doing the survey I came across a few things which I found is very interesting, so I thought to share it with you. Let's take a look. The cellar is a quite large cellar. It's about 24 meters long. It has all sorts of issues typical to them cellars. We can see the plaster is blowing in most areas. We can also see above the blown plaster tide marks, which basically are visible depending on how we hold the light. So yes, in this case, yeah, you can see it. There's a tide mark on the wall. This wall, the plaster is completely blown. Like this. We have two large dehumidifiers, one here and one on the other end, constantly running, and they are full with water. They filled with water in about a day. They have 4-liter tanks, so from this cellar, easily these extract about 8 liters of water per day. Then the second part of the cellar is like a vaulted ceiling. We have 6 different kind of rooms. And floor is typical, bricks on the ground. Here's the second dehumidifier. The walls are made of stone, except the last bit here, last half a meter, which are basically bricks. And on the ground, just salts everywhere. One interesting thing I wanted to show you and tell a bit of story about these blown bricks. Here. You can also see some blown stone or mortar over there. But let's find out what is happening here. So here we have the bricks are fine, and then we can see a brick here, which is basically kind of almost separating a chunk of brick. A part of the brick is separating from the wall. And here we can see the brick, which has already separated from the wall. Many old cellars, you can encounter these. You have the good bricks, and then you have the bad bricks. And what is interesting, this blown aspect of the bricks is not because of the humidity, not directly. What happens, the problem here are primarily caused by salt. Here is the ground, and water evaporates into the building fabric from the ground. So we have water movement, also known as rising damp, from the ground, and the ground water contains minerals or salts. Those are great for the plants, but not very good for the walls. And when the salts come up into the ground, from the ground into the building fabric, the water comes in and evaporates. Hence we have the dehumidifier there, which catches the humidity in this particular case and can be quantified. So we have a constant ongoing moisture movement from the ground upwards, and the water evaporates. So the moisture content of the wall, though it has seasonal variation, stays relatively constant throughout the year or changes slowly. So comes up, evaporates, comes up, evaporates. So it's relatively stable. The salt accumulation in the masonry is additive. So the water brings up the salts crystallize, and when the salts crystallize, they expand 5 to 10 times in volume. It's virtually the popcorn effect. We have a tiny popcorn seed which expands this time, and this salt crystallization breaks down the bricks. So the major issue when you see any of these issues in an old wall, you see that the plaster is not perfect, or the mortar is not perfect, or the bricks are blown. It's not because of the water, it's because of the salt the ground salts which rise from the ground or from the beaches, if it's a seaside property, and the crystallizing salts basically break down the bricks, and then we come across, you see that the brick is basically completely crumbly as a result. Now, in order to see what type of salts we have, I can just show you here. This is the floor, and we have tons of salts. I just come closer to the camera so you can see it. These are all salts. And these salts are in the wall fabric. These can be measured, these can be quantified with special salt measurement kits. We do it all the time. And the crystallizing aspect of the salts is which is creating these problems. We can see here, if you come with the camera, we can see the salt crystallization occurring at the bottom. You can see this white powdery stuff, which basically increases and it starts pushing the brick out. This is the paint, and if you poke it a bit, you can see that the paint comes off, and then the brick comes off, and the whole thing is crumbling off. And what happens, if enough time happens and we have enough salts here, the whole face of the brick, you can see it here, it will just come off in a big chunk, like this. And the more salts we have, the more crystallization, the more bricks we have. And that's the only reason we deal with rising them, or we pay attention to rising them to stop the salt accumulation and thus to stabilize the masonry.
All this data becomes very relevant when compared to some of the experimental findings from the research lab. We have taken two identical old-style bricks, one of them salty, the other one not. We exposed these bricks to ongoing wetting-drying cycles, exposing them to high humidity through a humidifier and low humidity through a dehumidifier. These were running on a regular alternating schedule 24/7. Initially, both bricks were intact. After a few weeks, the salty bricks started spalling and crumbling. After a few months and over 1,000 wetting-drying cycles, the salty brick became really damaged, while the non-salty brick stayed totally intact. This, under controlled laboratory tests, proves that the damage of masonry occurs due to salts, not high humidity.
Hope you found it interesting. Hope you learned from it. See you next time. Thank you.